Hello and welcome to this webinar, which we are doing on October 24th, 2024. And we're excited to have Elektor Senior Engineer Saad Imtiaz with us for a hands-on tutorial on setting up a LoRaWAN gateway, connecting it to the Things network and integrating it with Home Assistant. Saad, how are you doing today?
I'm doing fine. How are you doing, Ryan?
I'm great, thanks. At least I'm in a reasonable time zone. Sorry for you, it's a bit late there in Pakistan. I want to talk about a sponsor first of all. We have Espressif sponsoring us today, and Saad, you will be going through a lot with your Espressif during your webinar. So for the rest of you who are watching this, and thank you all for joining us. I see Frank de Hart is here. Discover Espressif's thread solutions from the ESP32H2 and ESP32C6 to their ESP Thread BR SDK. They deliver reliable, low-power connectivity for a wide range of IoT applications, whether it's Matter, IPv6, or the next big thing. Espressif's got the tech to keep your projects ahead of the curve. Now, as for LoRaWAN, it's a powerful tool for smart home enthusiasts, but not only at home, as Saad was just telling me before the show. You can use it at home in industry, but it's a powerful tool for developers, enthusiasts. It enables long-distance wireless connections for IoT devices. So whether you're looking to enhance your existing setup or build a new gateway from scratch, this session with Saad, our senior engineer, is packed with valuable insights. So Saad, you will take us through the full process from hardware requirements to real-time integration with popular platforms.
Yes.
Great. Well, I'll hand over to you then, Saad. Teach me.
Okay. Yeah. So hello, everyone. I prepared a small presentation. Before we get started with everything, I just wanted to clarify the difference between LoRa and LoRaWAN, and therefore I have a presentation for you guys. So let's just put it on display. Okay. So first of all, I would take time to talk about LoRa. So what is LoRa? LoRa actually stands for long range. It's a wireless technology that designed to send small bytes of data over long distances while using very little power. So the main concept LoRa is for the IoT devices, where battery life and range are key. So these are the two things. So it's more of a wireless protocol. Then what is LoRaWAN? So LoRaWAN is a network protocol which works with LoRa. So while LoRa handles the wireless communication, LoRaWAN manages how the data is transmitted. And how the transition between the servers and the application, that's the main process of LoRaWAN. So the main difference is LoRa is a radio technology which communicates between to each other. So if you have a walkie-talkie, Brian and I are talking over a walkie-talkie. So the wireless protocol which the two walkie-talkie is LoRa, and what Brian does after I relay the communication to him is LoRaWAN, so to speak. Okay, so this is a typical LoRaWAN architecture. So you have your sensors, let's say pet tracking, smoke alarm, trash container, water meter, and so on and so forth. You can have numerous type of sensors. And these communicate via LoRa to your gateway. So this is the gateway, and then this gets connected to the internet over Ethernet, Wi-Fi, LTE, and so on and so forth. And then these gateways are then connected to a network server. So a network server or the internet, and then it gets connected to an application server. So application server would include, let's say, the ThinkSpeak, DataCake, and so on and so forth. And then it gets relayed over to dashboards. Okay, so in simpler terms, I would say LoRa is the way devices talk to each other over long distances, and LoRaWAN is a system that helps these devices to send messages from the node to your dashboard. So in today's webinar, you guys will be learning how to set up your LoRaWAN gateway, connect it to Things Network, and then connect your sensor nodes to the Things Network. So two things will be connected to Things Network, your LoRaWAN gateway and your sensor nodes. And then after that, we will be going to display all the data we collect from our nodes to DataCake or Home Assistant, or we can do both. So what you need, so first of all, if you don't have a LoRaWAN gateway or you don't have the signals of LoRaWAN gateway around your house, maybe you're living in the countryside, then you're probably going to be needing to set up your own LoRaWAN gateway. Or if you want to have your local individual setup, you can have your own LoRaWAN gateway. But if you have, if you have the signals, you don't need a gateway. Yes?
I'm afraid I have to interrupt you. Your video quality is the resolution is very low. I don't know if you're having a bad internet connection or something. Could you try disconnect and reconnect, and then I will talk about our other sponsor.
Sure, I can do that.
Cool.
Bye-bye.
So as I said, we have another sponsor. It is Peak System. And they're a provider of interfaces, tools, and software for CAN communication, which originated in the automotive industry, but is also widely used in industrial and medical applications. So for more information, go to peak-system.com. And we'll post that in the chat as well. Peak System, thank you for being a sponsor. Now we will wait for Saad to rejoin. Sorry about the low resolution on those slides, but I think there might have been a connectivity issue on Saad's end. It's great to see so many of you in the chat. I mean, I started with Frank Dahat because he's a regular, but Raul Miguel is asking if we'll enable a recorded version. Yes, of course, this will be on YouTube. In fact, it's on YouTube right now live, but you'll be able to watch it again. Saad is back with us. That looks a bit better, Saad. Let's have a look at your slides.
Let me just share. Give me a moment. I think you can see it now.
Still quite blocky. You look good.
Well, can't say anything about that.
Okay, well, let me take myself off the screen, and then, yeah, that's looking a lot better. Thank you.
Okay, so moving on. Let me step back. So we're going to be setting up a LoRaWAN gateway. Then the thing we actually need is a LoRa module. I'm going to be using a LoRa module E5 from Seed Studio. You can use pretty much any other LoRa module, but I really like this one. It's really easy. The library is on point, and it's really easy to set it up. Then, of course, internet and a computer and a cup of coffee, because why not? We need it. Okay, so first of all, I'm going to be using the Dragino LPS8N LoRaWAN gateway. We have this on the Elektor store. However, there's another new version out there as well, which is also available on the Elektor store. It's the LPS8 V2. I believe both work equally the same, but the V2 is a little bit newer and it has a different UI in terms of functionality. They both perform the same. So to get started with it, you simply just power on your device. This gateway automatically turns its AP mode on, and you will see a name in your phone or your laptop, the LPS8N, and then this will be the last digits will be depending on person to person or device to device. It's basically the ending letters of the EUI. And then you simply connect to the browser, go to your browser when you're connected with the AP, and then type this IP address, and then the username and password is root and Dragino. However, I'm not going to be doing this, connecting to the AP mode and then going to this process. I have a much simpler process for this, is that you just simply connect your LoRaWAN gateway to your, let's say, router or your home network. And then you can use some sort of a tool like Angry IP Scanner or Advanced IP Scanner to find out which is your gateway. And then you can simply type its IP address, which I'm going to do right now. And welcome with that same screen. Okay, so once you, so this is the IP address on my router for this gateway. However, yours is going to be much different. It depends on various things, what your router defines. Okay. So this is the UI you will see on both. On V2, you're probably going to be seeing a V2 here instead of N, but other than that, it's pretty much the same. So for the first time you log in, this Wi-Fi AP will be green because, of course, it's automatically turn on. However, the LoRaWAN is going to have a cross on it, and it will have no Wi-Fi connection because it's a new device. So simply you click Wi-Fi. You simply enable Wi-Fi WAN client. If you're using Ethernet, then you don't even have to set this up. It's already connected to the internet. However, if you're using via AP mode, then you add your SSID, your passphrase, and simply save and apply, and it will connect to the internet. Once you're connected to the internet, you will have this green arrow, tick mark, sorry, and then, but you will still have a cross here. So to get the LoRaWAN started, then we click LoRaWAN. And I typically like the Semtech UTP protocol, because this way I can have two servers which I connect to. Normally, if in a single mode, basic station mode, you just connect to one server. So let's just do this first, and then I'll link it together how I get this server IP address and this setting. So the primary server we're going to be connected to is the Things network. It's already inside the setting. The server we're going to select is Europe. However, if you're in Northern America, you can select this one, or in Australia, you can select this one. The uplink port and the downlink port is 1700. For the next server, it's not listed. The DataCake is not listed, so you just simply, or you want to use a different type of server, you just simply select custom or private LoRaWAN, and you get this IP address. I'll let you know in a moment how you get this address. The uplink port will also be mentioned over there. So once you save and apply, I believe it takes a minute or two, and you will get a green mark here. And once you hover over it, you will see at the left side of my screen, left bottom corner, you see LoRaWAN process forward running online, and it's the server is connected to is the Things network. So once we're done with this, let's go to our Things network page, where we actually register this gateway so that we can monitor it.
And we're back. So I'm having a look at the chat here, as always, and we've got some good questions and people from around the world. I mean, I even saw someone from Aachen, which is where Elektor Labs is based. And Brett H., good to see you again. We have a question from Ben Martins here. He wants to know, is any permission required in order to send data over long distances?
I think, according to my research or what I know, this does not require a license in Europe, I believe. But yeah, definitely check in with your local authorities, though it does not require a license for this frequency. Yeah, if someone knows that if I'm wrong here, yeah, you can let me know. But in my area, and normally when I checked in Germany, it is, yeah, at the time I checked, it was pretty very legal.
Yeah, and we're in two different countries, and we don't know the rules for the entire world. But
Yeah,
I encourage you in the chat, if you know anything about that in your region, to drop it in the chat for us. I mean, we've got someone from Jamaica this time. I think that's a first for me. Now, Saad, you're obviously doing this without much interference from your neighbors and such, but have you considered security implications?
security implications for LoRaWAN.
Yeah.
So actually, once you connect it with the, let's say, the Things stack or the Things network or DataCake, you're actually, it's more like of a public. If someone else, let's say one of my neighbors have a LoRaWAN node, sense node, he can send data and view it on his platform once you register his sensor node. But if he does not has a gateway, he can use my gateway, and he does not have to enter any sort of protocol or some login information of my gateway. It just automatically happens. It's I would say it works like magic. No one needs any information about my gateway. However, you can check, let's say, Helium network. You can see where is each node located. However, if you don't put, let's say, location or define location of your node, it's perfectly fine. But it's I would say it's very safe.
Well, that's great. To Ben Martin's question about permission required, we've got some chime in here from Daniel Levine. No permission needed in the US. And Noel Bristow says no permission is required in the UK, EU, US, or Australia.
Yeah, other countries have to check with their local authorities.
Yeah, I'm not sure what the rules are here in South Africa, but I'm also sure the police have better things to worry about.
I believe it's not. It's it's 864 or 36 megahertz, so it's less than your phone. I don't think it get interfered with Wi-Fi at such a low frequency, so it's very legal, I would say.
Yeah,
So,
and that's right at the top of the UHF TV band, which they've discontinued analog television in, well, at least in the UHF band. We still have VHF analog TV, believe it or not, but they'll be shutting that off at the end of the year. But you said 860 megahertz or so. That was like channel 69 on right at the top end of the UHF television. Now, can I ask you about scaling? You can do this as a one-off, obviously, for your experiments and your, whatever you need to do around home. But let's say you are a factory or you have a big warehouse. How can you scale the IoT network using LoRaWAN?
well, typically, I would say LoRaWAN would be implemented where range and battery-operated systems are being used. So, let's say in a hotel, in every room, let's say if they already made the hotel, they didn't made any significant type of, I would say, an option in their rooms where they can power the sensors which they have inside. And then let's say they install a new sensors all across the hotel rooms, so they can use LoRaWAN. So there will be a battery powered sensor, let's say temperature or humidity, and I don't think it has some sort of limit. I don't know about that. I can't comment about that, but it's pretty enormous. And the range wise, it's 5 kilometers and even more if there's a good line of sight. I've seen people. Well, the word on the street is it goes till 20 kilometers as well. So, but it need to have a really good line of sight. So
Yeah,
I think farms, hotels, industrial areas where battery powered systems are being used, and it needs to be lasted for a long time. This is the technology to go for.
Yeah, line of sight is obviously important at those frequencies. The UHF antennas I was talking about, VHF was 175 megahertz to 255 megahertz, and that reminds me, what MF says. To my knowledge, worldwide, no permission, but different frequency bands. And you're only allowed to send 1% of the time. So duty cycle, 1 to 100, which again reminds me of CB radio. I think some people are still using CB radio, truckers maybe, I don't know. But that was on 27 megahertz. And yeah, it was free to use, no permission required, but you couldn't be on all the time. So that's interesting. Duty cycle 1 to 100. Do you know anything about that, Saad?
No, I don't know that, but definitely there is some sort of limitations. Not everyone is going to be using, let's say, 686, 868 megahertz. It's for Europe. It's for the LoRaWAN 868 megahertz is the selected one. So let's say if someone is in Asia, I would say I think they have 433. And for US, we have 915 megahertz. So then it makes legal. So you cannot use 868 in US. They define 915, so you use that one. So that's why it differs region to region. Frequency is different, but the protocol is the same.
Cool. And while you talking there, I was looking at this URL, which is very useful. It uses the ISM band, which is usually license free. I want to have a look at that web page. But another question from Abo Berg: can I use a public gateway instead of using my own?
Definitely. Like if you don't have one, definitely public gateway is the way to go. I didn't had one in my area, so that's why I have one. Otherwise, I don't need it. I just have to register my sensor node or the package where it contains all the sensors and the E5 module, which I was talking about. You register it with the Things network, which I will go really shortly through that, and then you will start getting data in your application, and then you can forward that data over to different platforms. But you don't need it if you have one around, like in your surroundings. You can check the Helium network. They have a map. It shows pretty much every sensor node or the gateway which is installed, and you can check if it's in your area or not. And I think on the Things network, you can also see where the nodes are installed, and it has good range. Normally, my gateway is indoor, but these gateways, people put it on the top of their roofs, so it's a lot of range on those things.
Yeah, and you're frequency hopping all over the place. So, I mean, we've got Bluetooth, we've got Wi-Fi, we've got, now we've got LoRaWAN. How do you think the future will pan out with wireless communication for Internet of Things devices?
I cannot comment on that. I'm just aware of the technologies which are current technologies. I think NB IoT is also IoT NB or NB IoT is people are working on that, but I'm not totally aware of that because it's not area of, I would say I'm not an expert in wireless communication. But Sigfox is also another one. But I believe for power, low power, long range, this is LoRaWAN is the way to go. And also there's a really nice presentation by the Things Network. You can check out on their YouTube channel and also on their documents where they make a nice comparison between these current wireless technologies for IoT networks. I'll drop a link shortly if I can find one.
Yeah, please do drop the link. And for anyone with questions, I'm looking at the chat again, people from all over the world. We've got Chase's Crust who says hi. And we've got a good comment from Gus Altobello Jr. There are maps showing coverage, good in urban, almost nothing in the New York suburbs. Well, I mean, suburbs be suburbs, right? Even though you said the range could be like 10 kilometers, Saad?
Yeah, if you have a good line of sight. So if, let's say, if you're a really populous area, very, I would say, urban, then it might reduce to even 500 meters or 600 meters. But if you're in a rural area, countryside, you put a node on top of your house, and then it can reach, I think, 10 kilometers easily with a line of sight. The line of sight is very important in wireless communication. Either
Yeah.
it's LoRaWAN or any other, it is important.
Obviously, at higher frequencies, for example, CB radio, you don't need line of sight, but that's down at 27 megahertz. Looking at some of the questions here. Home Assistant, you're using the Home Assistant software. Could you walk us through a real world example of how you integrated LoRa with Home Assistant?
Real world example. So lately I did a project where I made this sensor node, which is solar powered, and it monitors the soil moisture, carbon dioxide, temperature. And I was thinking of adding more sensors to it on, let's say, on my roof or on my mumti, we call it here. On the mumti, there's no Wi-Fi at all. You don't get the Wi-Fi. And I wanted to have a weather station type of scenario on top of it. And then to put the Wi-Fi or buy a router, route the cable Ethernet so that I can get signal on my roof. Or this is easier. So I just installed LoRaWAN Gateway and put a sensor node, which is solar power, so I don't have to charge it at all. It's low power, battery operated system. And in that case, I can easily get my data onto my Home Assistant or DataCake or any type of dashboard scenario. Okay, let's move a little bit back. Okay, now you own a really big farm or a small farm, or you really like your plants. You're not gonna get your Wi-Fi typically on in your lawn or in your small, garden. So you install these LoRaWAN LoRa sense nodes, sensor nodes over there in your lawn and garden, and then they will transmit data to your gateway, and then you get your data on your Home Assistant or any dashboard out there.
That's cool. I'm just looking at this Wikipedia page, and it's fascinating me. If I can just share that with you. There we go, the ISM radio band. Thanks for sharing that in the chat, Thomas. I'm amazed at these frequencies. For example, 6 megahertz. That's much lower than I thought we were doing RF transmissions on. And it goes, well, there you got 902 megahertz, close to what you were talking about earlier. But this goes up to 244 gigahertz. The highest I've heard is like 12 gigahertz, maybe up to 19 gigahertz for satellite TV. But wow. Saad, have you worked with frequencies like that?
Well, I in the aviation industry, I worked with the radar team, but I was not the radio guy. So let's just put it that way.
So no idea what the radar frequencies were?
They're in gigahertz for sure, but I'm not sure how much, because it was not my department at all. We're talking about aircraft radar, so definitely it's going to be much more than a megahertz for sure.
Yeah, and then thanks to Thomas for that link, but Noel has a fact here. LoRa does not use the ISM bands. Interesting. And then from Gus Altobello Jr. again, I've been aiming to have such a soil monitor for my daughter's community garden plot, several blocks from her home, thinking LoRaWAN supercapacitor, solar hidden in an old solar light, because it's a public space. You don't want it to be stolen. That actually sounds like a good use case, Gus. Supercapacitor, though, you're going to use that as a battery, though, then the solar will charge the capacitor, I guess.
Yes, and I was actually thinking of that solar capacitor system. When I was when I was in the embedded world, there was a company called MBeak, and they had a lot of these type of demonstrators where we're using solar capacitor with a small solar panel. getting the data and transmitting the data. I believe it was LoRaWAN as well. So yeah, this type of stuff is really good.
So as you said, line of sight is important at those frequencies. And I've got a drone which claims to have up to 12 kilometers of range, but here in the city, I send it maybe 600 meters away, and next thing I've lost signal. So in terms of LoRaWAN, what sort of steps could you take to increase the coverage
Of your drone?
of your LoRaWAN network?
Maybe
When you're in
put
the
it
city and you get a lot of interference and...
Well, interference is a devil. I mean, you cannot stop that. But I would say if you put your gateway at a higher altitude, and then the sensor needs to be there as well, so that there's a line of sight. Like let's say if you're lost in the forest and you cannot communicate with your teammate over a walkie-talkie, you get a little bit to a higher ground. So that's the only way.
Yeah, and speaking of my drone, Frank de Hert has a remote control model airplane that's on the 72 megahertz band. Geez, if we keep going, we're going to do all the megahertz. 27 megahertz for CB and 72 megahertz. If I recall correctly, possibly remote control airplanes used to be on 27 megahertz. But you know, I'm thinking 40 years back, so I'm not absolutely sure. And then Thomas is back saying that it doesn't use all the ISM bands, just some. The EU 868 might fall under SRD bands. So we have another link there. And Thomas, besides the umlaut in your name, the fact that you put de.wikipedia.org, I'm trusting you're coming in from Germany. Now, Saad, if you look at technologies such as Wi-Fi, I mean, you've got to have a gateway for that, or Zigbee. Why would you go with LoRaWAN? Because I haven't used LoRaWAN yet. I mean, I live in a city. There's plenty of cellular communication if I want to put something up in a tree to monitor traffic or whatever. But you going with LoRaWAN, what's the advantage of that?
Again, battery-powered system. So I don't believe Zigbee is. I think, of course, it can anything be battery-powered, but it's going to take too much power. With LoRaWAN, I think the project I did, it was taking around 10 microamps in sleep mode, and it can go
Microamps.
beyond. Yeah, it can go even less than that if you have, let's say, a power latch system with external RDC. Yeah, it has long range. It uses less power, so it's you can use that, but it's so you would need a gateway for that, just like a Zigbee thing. A Zigbee hub, you would need a Zigbee hub. It's connected to your network, and then you have to link it to that. It needs a gateway, but that Zigbee hub is only dedicated to you. But a gateway is shared by everyone around you. So if I put a gateway right now, which I'm going to show you quite shortly, you will see that anyone can. I didn't use the location. I didn't assign a location to it right now, but I can do that, and then people can see. Okay, there's a let's say my neighbors or anyone. Hey, there's a gateway right next to me. I don't have to use my own gateway, and then they can collect data from their sensors to their dashboard or home assistant.
Interesting. And Frank is back with the comment. Used to be the 35 megahertz band, but his 72 megahertz transmitter is from the 70s to 80s. Yay, someone as old as I am. 72 megahertz is reserved for flight models, for example, in Belgium. That's according to John Orbit. Are you going to show us your gateway, Saad?
Yep. I'm going to show you how to set it up or link it with the things stack.
Great. Let's add that to the stage, shall we?
How do I, can you make it full screen so everyone can see? There you go. Okay, so signing up for, you just sign in to the Things stack. I'm not gonna go through that process. It's very simple. You go to the Things network, you sign up, and then it's free, so you don't have to worry about anything, paying or credit card. Once you sign in, they recently actually changed their, I would say, their UI, and I think it's a little bit better than before, a little bit more cleaner. Okay, so let's get to the register gateway, how to register it. So firstly, you simply click register gateway. I'm gonna just type a random number. What this gateway normally is gonna be at the back. It's gonna be in a QR code, or it's gonna be written EUI. You can also check it from here. So if I go to LoRaWAN, this is the EUI. So one time it's registered to someone, no one can use it again. So there you go. So I can simply copy paste it there, but it's going to say it's already registered. I'm going to just do it as an example. And then I just give my gateway a new name. Let's say my new gateway. It needs to be all small. And then gateway. So here you have to select this frequency plan. It needs to be according to your, let's say, region. So let's select Europe, for instance. If you're using a LoRa basic station, then you can select this one, but I prefer the UET one, which I was mentioning before, the UDP. And you can register, and it's going to say already exists because it's already there. So once you do that, everything is done. It's going to take, let's say, a minute or two. Sometimes it can take more than that. It depends on the Wi-Fi speeds, but you can say, hey, last activity was 8 seconds ago. You can see the connection status, how many things you sent, how many you received, and you can see all the channel or duty cycle utilization. And once you're here, then you can set it. So let's pause. Okay, so we have set it up with the Think stack. Now we have to do the DataCake one. So for that, it's almost the same process. Let me just transition my screen real quickly. Okay, so for registering your node on DataCake, you simply just log into DataCake and you go to gateways, and it's the same process. So you add LoRaWAN Gateway. It's going to ask you for a name. It's going to ask you for a gateway EUI. It's the same EUI. You can use it. So this is a different, I would say, server. So it won't matter if I use the same EUI again, because we're registering the same the gateway to different servers. So I cannot use a same EUI 2 times on the same server. Just wanted to clear that out. So you simply paste that. You can select which region, the proper frequency for your region, and then click Gateway. Once you've done that, it's gonna pop up easily, and you will see this online green stuff that it's online. You will see the uplinks and the downlinks. From my sense nodes, I'm not sending data to the gateway. Sorry, I'm not sending data from the gateway to the node. However, you can do that if it's online. But I'm actually just receiving the data. So the uplink is my sensor node is sending data to the gateway, and the gateway is then sending data to the internet. Okay. So we've done the process of adding your gateway. Now, how would I add a sensor node. So for that, I have a small setup here. Let me go on stage. Okay, so here you can see a small, this is the ESP32C3. This is the SCD carbon dioxide sensor with temperature and humidity. And this is the my LoRa module, the E5 by Seed Studio. So we're gonna simply connect it to our computer, plug everything up, and load the example. However, I am using the code from GitHub, which I recently made for my project, and I can just share that GitHub repository shortly.
Check your audio there, Saad. You've got a bit
Oops.
quiet.
Oh, sorry. It has a capacitive sensor and actually got pressed. Where did I start get cropped from the audio?
So don't worry about it.
Okay. Let me just put up the GitHub repo shortly, or I'll just share it in the chat really shortly. Can you, Brian, can you kindly make this screen full screen? Thanks. Okay, so to get started or to connect your sensor node to your ThinkStack, you simply have to make a new application. So I already make it, but I'm going to go through the process of making an application. It's very simple. So you simply write your name, hey, my app, or whatever the name you want. This is the ID of it, and it's going to be used when we're making the integration between the Home Assistant and Gateway. So make sure it's a good one. Then the name for it, and then you simply create application, and it gets created. For this webinar, I made a small example called FarmGuard. And this is, so the ID which I selected is FarmGuard V1. And this is the main application, but now you have to link your device to it. Let's say your sensor package. So here is my Arduino code. I'll share it in the GitHub repository shortly. But here's the Arduino code. Is simply what it is defining the hardware serial for communication between the LoRa module with the ESP32C3. Then we're going to talk about this API key, app key. And once you connect it for the first time, you will also see the dev UI and the app UI of the module. Every module will have a different one. They do have a QR code on top of it, which is a little bit hard to scan. So if you cannot get or not able to scan it easily, you can simply use this code or use the example. The dev UI and the app UI gets visible in the serial monitor, which is pretty easy. I do it that way. Okay, so now we want to add this device. So you simply click Add Entity and register end device. And here, of course, I'm not using the end device, which is in the LoRaWAN device repository. It's going to be something of my own. So you select the frequency of which your LoRa module operates. Then I believe it's 1.0, yeah, this one. And then you write the join UI. It's actually the app UI. So you just copy it, paste it, confirm. Then you add the dev UI here. I'm going to simply just generate it, but you can change it as well by the AT commands of your module, but it's going to be already there. So you just copy paste that, and then you generate this app key, which you can paste into your code where it requires it to be pasted, so that your the think stack and your gate the node gets connected. Okay, so once you've done that, you can write the name of your device ID. Make sure it's a good one, and if you have, let's say, 20 devices, make sure it's in a format so that you don't get lost doing that. So once you click register end device, you're going to see something like this. And if you did everything correctly, you're going to see last activity at some time ago. It depends upon how much is the I would say the send rate of your, because right now my code, what it does is that it wakes up, it collects the data from the sensors, and then it basically uploads or sends it via LoRa to my LoRaWAN gateway, and then it sleeps for 1 minute, and then it wakes back up again and does the same stuff. So as you can see, 1 minute ago, and when it reaches 60, it's gonna go 0 again. Okay, now we can see the carbon dioxide is 0 and the humidity is 0 because the sensor got a little bit disconnected. However, you can see the moisture, soil moisture, which is actually the noise of the ADC. But yeah, we're collecting data, which is important. And how to get this data in this way is that you have to format, or you have to do a, I would say, payload formatter. You go to payload formatter here. And then the most easiest way is to ask ChatGPT to make a payload formatter for your device. However, if you don't want to do it this way, it is pretty much very easy. There's a guide in the GitHub repository. You can follow that, and you can do this payload formatter that way. I'm not going to explain through it because then I'm going to be explaining bytes and everything. So you do it this way, then you can do a payload test because once you're going to send you're going to be sending a byte string, and you can copy that byte string, which pops up in your serial monitor. You can paste it here, and you can see if it's decoding it properly. Okay. Yeah, confirm. All right, so here we are. And now what we want to do is, the thing is that the Think Stack, it's not a dashboard where I can see all this data correctly. So to see this data, we need some sort of a dashboard, let's say DataCake or Home Assistant. We're going to start with DataCake. It is pretty much very easy. For that, you just simply go to integrations and webhooks. Already made a webhook for myself, but you can simply, as you can see, there are many platforms for dashboards of IoT stuff. I select DataCake because it's easy. Simply select that. You can put a name, and then the API token. You get this from DataCake, and I'm going to show you how you get it. So basically, go into devices, you click add device. Now if you notice, we're in DataCake right now. You click add device, LoRaWAN. You can make your own product, or you can select it from the template. However, we're going to select a new product. You can say test node. Next. And now, okay, so there are two ways. If you are using only the server of DataCake, you can go the easy way and select the DataCake LNS. But we like to do things a little bit hard way, or so that we can cover more stuff. You can select ThinkStack, as ThinkStack is also the server, and we just linked our device to the ThinkStack network. So we're going to select that. Then it's the dev UI of your node. So your sensor node, which we added, we uploaded the Arduino code onto it. You can put a name for it, a location, a tag for it, and then you simply just click next, and you can select a free plan, and from there on out, it's just you choose the plan. Okay, so let's just cross that, and let's just think that you did that, and you added your webhook. I would say you got that IP address. To get the IP address, you go to, I believe, account settings and your API token, and then you can copy it from here, and you will paste it over here, and then you will have this webhook up and running. After that, it's good to enable storage integration. If you're using it with the Home Assistant, you need to have this enabled. Otherwise, you will have set up pretty much everything, and then you say, okay, it's not working. And the only thing which was wrong is that you didn't activate this. So I would say just when you do webhook, you just start this, click enable this setting anyway. Okay, so we made the integration between the ThinkStack and DataCake. However, on the ThinkStack side, we need to do a little bit more setting to get the data correctly. So before that, before setting everything up, everything is going to be 0 or minus or some false information. You go to configuration. You can type the name of the device you want. The payload decoder is going to be the same information or the same code which we used in the ThinkStack. And yes, so we have to set this up. So simply click change. You will write the TTS device ID. So this is the device ID we set up in the ThinkStack network of that sensor node. Then this depends region to region. As I selected the European server, I'm gonna just simply type it here. Then the app ID is the same, and the API key. So you have to generate this one in order to paste it here. You simply go to the Things Network and you go to the API keys. And here you can copy this API key, copy it, paste it here, and hopefully everything will be working fine. So once you're done with this, you will start getting data. I just disconnected my device, and I'm going to just simply reconnect it again. And you're probably going to see data coming up here. So meanwhile, this comes up. Let's integrate it with Home Assistant. With the Home Assistant, it's not too much copy pasting. So simply you just make another API key. And this time I will make it Home Assistant. And then create IP. Just simply copy it. Copy the ID, and then you go to Home Assistant. Once you're in Home Assistant, you go to settings, then devices and services. And I already have the Things Network here. However, you can add the integration simply like this. There, and there it is. And you can add the application ID. So the application ID is here. The farm guard, this one. So this, you copy simply this and paste it here. And the other API key, I have to copy it again. 1 second. Okay, and you simply paste your API key. Submit. And you can define an area for this in your Home Assistant. Let's just put it at home and finish. And now, as you can see, the farm water node 001 is visible here, and the data we received were received 22 before as the same. We are getting viewed here, and as you can see, this new data has been sent. So that's pretty much it. I think I went a little bit quickly, but you can pause the video in the middle to cover everything, or do it when the stream is over, as it's going to be available on the internet, YouTube.
Yeah, you can pause it. You can play it at half speed. Saad, I noticed that the API key was blurred out. If someone were to get your API key, would that what sort of risk would that pose?
I think in my situation, he knows the API key, and also he knows my the ID, the application ID. So then he can just view my data. It's not like he's gonna hack my sensor node or my WAN network. But however, you can change it, generate it. You can send an expiration date for that API key, and generate a new one. I'm gonna do that anyway. So yeah, just to stay safe. But yeah.
Okay, I'll be going through some comments, including this one from Neil Horder. He's given us a nice URL there about the duty cycle, which you see there. Interesting. I don't know how they police that, though. But before we go on to more comments, I want to talk about our giveaway, which you're used to here on the channel, and you'll want the code word. So we're giving away ESP32S3 DevKit C 1U N8R8. Yeah, those model numbers are never easy. But let's cut it down. It's a powerful entry-level development board. It's perfect for your next IoT or embedded project. It's got 8 megabytes of flash and 8 megabytes PS RAM, plus Wi-Fi and Bluetooth low energy capabilities. So it's ideal tool for developers looking to explore neural network computing, signal processing, whatever you want. And the URL is here. And the code word today is LoRa, nice and easy. So just go to that URL, elektormagazine.com/elektor-webinar-giveaway, and put in the code word, your email address, and 5 of you will be winning one of those ESP32S3 dev kits. Now, back to the comments. And we've got some great feedback. Michael Regensburger says he would like to do a LoRa project at his ski resort, and they would like to place weather sensors on various mountains, but so far only in the concept phase. Well, that's good enough. At least you're doing something. Here's a question from Gus. So there's a choice to be made at setup. Is it Things Network versus DataCake versus whatever? Choose one and live with it? Is that what you did?
I believe so, but you can change easily. It's not like yes, for the gateway, as I showed, you can choose 2 of them and just live with it. No big deal. But then if you want a different type of dashboard, then you can do the integration between the dashboard. Let's say I would say, I don't know any new other dashboard. Let's say ThinkSpeak, yeah, by MATLAB. And then you can, let's say you want that dashboard. So instead of DataCake, you can, I would say that in the Things Network, you can generate a API key for that dashboard, and you can use that dashboard. However, yeah, in these free dashboards, you will have a limitation of storage space, like the data 1 month ago, 2 months ago, 3 months ago, you won't be able to see it. But that's why I like Home Assistant, is that it's on your local network. It's going to be using your own storage. You can simply link it up with your Home Assistant, and I think you can even see the data 2 years ago, if it's that old.
A question from Gerard. Can you tell us in which steps you have an API key? I saw that earlier, Gerard. So rewind the video and you see where Saad got his API key. Gus has a question. Can you have multiple readers that use the same IDE or API key?
No, I didn't understand the question quite right. But if you meant by readers as the dashboards,
the end device,
end
I'm
nodes,
guessing.
the end sensor,
Can you have
then
multiple nodes with the same API key?
so this is one UI. I would say this is one UI, and this is connected to my sensors, and this guys can be connected, I believe, to one a register to one only. No, I might be wrong. I didn't test it, but maybe it can be connected to both of these platforms. Let's say the Things Network and also DataCake, because they both support registering the device. If you meant by that, then I believe yes, one can be connected to other. But and as I mentioned before, then you make an application. So inside an application, you can have hundreds of these sensor nodes, and all would require only one API key, which you can use to display data on different dashboards. So each dashboard would have their own API key, which we did.
Great. I hope that answers your question, Gus. Comment from Paul. No, sorry, Puzzy. I bought a couple of LoRa devices from Elektor and currently use one of them, the LiDiGo T-Beam, as a Meshtastic node. Any experience with Meshtastic nodes, Saad?
I really want to get in, get started with this Meshtastic. It's actually a really good thing. You don't have to use internet, or you don't have to use your cellular connection. People have installed, there's a huge community, they have installed these nodes, or a link between these two devices, and you can use your phone to message someone through this small device. And what it does is that it connects with your phone via Bluetooth, and they have a Meshtastic app, and that app, you can make a message. I think they have channels as well inside, so one can send a message through LoRaWAN to their friend, and it's encrypted, so it's safe. And if, let's say, cellular networks are down, you can use this. But then, of course, line of sight, and then range, and then all the things come. But it's encrypted, so if you want to do it that way, then you can do it.
Yeah, and if you say line of sight one more time, we're going to have to go back to 27 megahertz. Anyway, it looks like we've gone over time as usual, because these are such great conversations. We could go on for another hour, but we're not allowed to. So big thank you to you, Saad, for joining us all the way from Pakistan and telling us about LoRaWAN and the Things Network and integrating with Home Assistant. This is yet another one I'm going to have to watch again. I have a Home Assistant green here, so I'm going to follow along in the video and try and set up my network here. I'm pretty lazy in that regard, because I've got Wi-Fi and basically everything's on Wi-Fi. But you know, again, in the big city with Wi-Fi and cellular, all great. But I do need to up my LoRa skills. So thank you for joining us, and also thank you to everyone from around the world who joined us. And you had some great comments in the chat there. Thanks very much for those about the permissions and the different frequencies around the world. For example, this one. I'm not going to read it all out loud, but there's some great information there. So pause here if you want, and I will have a look at that. But thank you to everyone who joined us, including Frank, who's a regular and was first online here. Thanks, Frank. And thanks, Saad, for joining us. And thank you to everyone. And also, good luck with the giveaway, because I wouldn't mind one of those ESP32 DEF kits. So good luck to the 5 of you who are going to win. And thanks to everyone, and thank you. And stay tuned to Elektor TV for more of these live streams.